In this section, we will talk about implicit differentiation. Again, not something that you don't already know. A quick recap on what is this implicit differentiation about. You differentiate term by term, all right, especially when you have things like expression like this, like you have x squared minus 2xy plus 4y squared equals to 28. How do you differentiate this? How do you solve this? We have to use this idea of implicit differentiation. Basically, you differentiate term by term. Then you differentiate this first, then differentiate this, then differentiate this. But how do you differentiate all these term by term? The idea is chain rule and product rule, basically it. Alright, so to generalize it, you differentiate with respect to y first, then dy dx. So I give you an example, alright, in the next slide. Okay, if you look at example, the next example here. Okay, there are 4 parts to it, A, B, C, D. Let's solve A and B, which are the easier part. Bearing in mind this thing here, I'm going to write this here like that. So differentiate, correct? Differentiate with respect to y. Basically, if I were to use it very hard and fast about it, I'm going to differentiate this with respect to y, yes, and then multiplied by dy dx. So when I differentiate with respect to y, obviously I get 1. Therefore, the answer is 1 times dy dx, which is actually dy dx. Now, this is a very trivial example. Many of you would be able to jump from here to here quite directly. Okay, if you're doing enough. Now, let's do a bit quicker for your differentiate y squared. So basically, you want to differentiate this expression in terms of y first, correct? Which is d over dy, y squared multiplied by dy dx. Now, just jump very quickly, you get 2y dy dx. Most of you will be able to jump from here to here, but you must know why. Basically, this is chain rule. Okay, so let's take a look at C. All right, C. Now you know why I need to use product rule, because it's a product of 2 functions x and y squared. So using product rule, you will differentiate y squared and then keep your x, multiplied by your differentiate x, keep your y squared. But bearing in mind your next line over here, all right, is what? When you differentiate y squared, you don't just get 2y, you will actually get 2y dy dx. All right, and then you will get a y squared. Yes. All right. When you differentiate, I repeat, if you differentiate y squared, you get 2y dy dx. Then you get a 2xy. To make it prettier, I beg your pardon, it should not equal. It's a plus y squared. All right. So C is probably the more difficult one of the two. Let's take a look at D. All right. Again, whether it's y or what, you differentiate with respect to x. The question asks us to differentiate with respect to x. I will differentiate this with respect to u times du dx. So basically, you will get a 3u squared du dx. So it can be u, it can be a y. The principle remains the same. Okay, thank you.